Hello everyone, welcome to our new video. Today we will study about heat treatment and its properties. So first of all, let us define what is heat treatment. Heat treatment is a process in which a metal is heated to a certain temperature and then cooled in a particular manner to alter its internal structure. This is done in order to obtain desired degree of physical and mechanical properties. These properties can be anything. Generally, these are brittleness, hardness, and softness. Today in this video, we'll study about various types of heat treatment techniques, which are first is annealing, second is tempering, third is quenching, and fourth is hardening. So now we will discuss about these types one by one. First is annealing. Annealing consists of heating a metal to a critical temperature and then cooling at uniform rate that will produce a refined microstructure. The rate of cooling is generally slow and usually we cool it in air. Now let's see the effect of annealing. Annealing is most often used to soften a metal for cold working, to improve machinability, or to enhance properties like electrical conductivity. It increases the softness and ductility of material. It removes internal stresses of metal. Our next type is quenching. Quenching is a process of cooling a metal at a rapid rate. To harden by quenching, a metal must be heated above the upper critical temperature and then quickly cooled. So the difference between these two is that the temperature is very high. Cooling may be done with forced air or other gases such as nitrogen. Liquids may be used due to their better thermal conductivity such as oil, water, a polymer dissolved in water, or a brine. Let us quickly look at the effect of quenching. Quenching increases the hardness of material, but it also increases the brittleness of material. The third type is tempering. Tempering is usually performed after quenching. So first we perform quenching and then we perform tempering. Tempering is a heat treatment technique applied to achieve greater toughness by decreasing the hardness of alloy. The reduction in hardness is usually accompanied by an increase in ductility, thereby decreasing the brittleness. Tempering is accomplished by controlled heating of the quenched workpiece to a temperature below its lower critical temperature. So our last type is case hardening. Case hardening is also called as surface hardening. What happens here is that we harden the surface of a metal object while allowing the metal deeper underneath to remain soft. So that means the outer layer is hard and the inner layer remains soft. The first type of case hardening is carburizing. Carburizing is a process used to case harden steel with a carbon content between 0.1 and 0.3. In this process, metal is introduced to a carbon-rich environment and elevated temperatures for a certain amount of time and then quenched so that the carbon is locked in the structure. The next type is nitriding. Nitriding heats the metal in an atmosphere of ammonia gas and dissociated ammonia. The time the part spends in the environment dictates the depth of the case. No quenching is done after nitriding. The last type of case hardening process is cyaniding. It is fast and efficient. It is mainly used on low carbon steels. The part is heated in a bath of sodium cyanide and then it is quenched and rinsed in oil or water to remove any residual cyanide. This process produces a thin, hard shell layer that is harder than the one produced by carburizing. The major drawback of cyaniding is that cyanide salts are poisonous. So this was all for heat treatment video. If you like it, if you found it informative, then please like the video and subscribe to our channel. Thank you so much for watching.